For today's lesson, we're talking about learning target 4, which states that I can set up and graph a linear inequality given context. So here you're going to be given word problems. We'll need to define our variables, set up our inequality, and then graph and test for shading to see where our true solutions are. So for number 1, we have a yearbook company promises to give the junior class a picnic if they spend at least $28,000 on yearbooks and class rings. Each yearbook costs $35 and each class ring costs $140. Set up and graph the inequality to show the options of yearbooks and class rings they can buy in order to reach their goal. So first we want to be able to identify what our variables represent. So yearbooks and class rings are the unknowns, how many we should get. So let's say X is the number of yearbooks and Y is the number of class rings. Now based on the word problem, there are some other key pieces of information that we'll need. So it looks like at least 28,000 will be a key, 35 and 140. Notice that $35 goes to the yearbooks, $140 is talking about the class ring. So these will be kind of set up in standard form. So because you're talking about X as yearbooks, 35 should go with X, 140 should go with Y because they're both talking about the rings. When they say at least, that means that it would be a greater than or equal to sign, and that would be 28,000. So there's our inequality. So then from there, because it's in standard form, I'll need to use the X and Y intercepts to help me graph. So I'll plug in 0 for my Y to find the X intercept. In doing so, that gets me 800. And so then our x-intercept will be 800, 0. Then I'll figure out what my y-intercept is by plugging in 0 for x. And that'll give me a value of 200 for y. So then my ordered pair would be 0, 200. Now, because you have a graph, remember you can make the scale to fit your needs. So because x needs to get up to 100 or 800, I can go every box or line is 100. So I can easily get there. So I can stop once I get to that point. And then the other side, since I need to just get to 200, let's make it so that we can go by 20s. So notice that I would pick 2 different scales here. Because it really doesn't matter how we go about it. We could have made the scale the same as the other one for x, and that would have been perfectly fine. So I graphed my 2 ordered pairs, 800, 0 and 0, 200. Because it's a greater than or equal to sign, that means it's a solid line that I graph between the 2 points. And then from here, now I need to test to see where I shade. So I'll use 0, 0, which is pretty easy. Plug that into my inequality. Okay, and then I'll just get 0 is greater than or equal to 28,000. And so 0 is not greater than 28,000, so that's a false statement. So everything to the right side or not including 0, 0 is what I'd shade. For number 2, Sabrina is decorating her bedroom. She has $300 to spend on paint and new bedding. A gallon of paint costs $14, and a new bedding set costs $60. Set up and graph an inequality to show the options for her to stay under her budget. So here, same thing like we did in the last one, we want to define our variables. So it looks like we have a decision to make between paint and bedding. So let's say X is the number of paint cans that we need to buy. And then let's say Y is the number of new bedding sets that she can purchase. And then from there, I need to identify the other important pieces of information. 300 seems to be important. $14 and $60. Remember that 60 goes to your bedding, 14 is going to the paint. So when I write my inequality, I need to take in mind that they don't really have a inequality wording here for 300. But think about it this way: she doesn't have to spend all her money for paint and bedding in this scenario. So it's almost like 300 is a max, essentially. So 14 would go with the x, 60 would go with the y. This would be another standard form equation. So because it's a max, we would say at most she can't go over 300, so 300 should stay the biggest number. But we can spend all that money and go right up to 300 if we want. Okay, so because it's a standard form, we'll use x and y intercepts again to help us graph. So plugging in 0 to find the x-intercept for y, that gets me 21.4 here. This is a little decimal, and that's okay. So that's our ordered pair, 21.4 comma 0. Then I'll plug in 0 for x to find the y for my y-intercept. In doing so, solving will get me 5 for y. So that gives me 0, 5. So here, same thing, I can change the scales to fit my needs. So because I just need to get up to 21, I can just go by 2s on the x-axis. And then I can just go by 1s on the y-axis if I want. So I graph those 2 points. 21.4 will be in between 20 and 22. So we'll sneak it in there a little bit, and then same thing, because it's a less than or equal to sign, it'll be a solid line for this one. And then from there, I need to test the point. So 0, 0, plug it in. That'll get me 0 on the left side. So 0 is less than or equal to 30, 300, and that is a true statement. So then we shade on the inside. Okay. Better shake, rattlesnake.